in 7.3 part 2, we're just going to take a look at some story problems with areas of triangles. So just at the top of your notes, I listed out our different formulas for finding area, right? If we're given two sides and the included angle, we would find our area this way. Given two angles and a side this way, and then all three sides, this is our formula. Okay, so let's just go through a few example problems. In this first one, we just want to find the approximate area of the Yukon. Okay, this is one of Canada's provinces, right on the northwest side of Canada. And we're given the side lengths, the approximate side lengths of this triangular shape. So if I know all three sides, I'm going to use Heron's formula. So the first thing, remember, that we need to do is calculate S. S is the semi-perimeter. So I'm just going to add all three sides up. And divide that by 2. So if we put that in the calculator, we get 1,637. So then I can take that value and plug it into my area formula. So we'll have the square root of 1637 times 1637 minus 1289 times 1637 minus 1063 times 1637 minus 922. Right? And we would just plug all of that into the calculator. And if we do that, we get 483,529.4481. Now, I don't think this question specified what to round to. So let's go to 2 decimal places. Generally, if we're talking about land, we would go to 2 decimal places. So this would be 483, 529.45. And in this case, we were talking about square kilometers. So make sure that we label these answers. Okay? So that was a pretty straightforward one, right? We were given all the information we needed to just plug into our formula. So let's take a look at the second example here. Okay? It says undeveloped land in a popular resort area is selling for $3 million an acre. So this is the information that we know. We know one side of this lot is 299 feet, and then these angles here, 42 degrees and 65 degrees. So first, we want to find how many acres this lot would be, and then we want to compute the cost of the lot. So this is going to be an important conversion factor, right? 1 acre is 43,560 square feet. So let's find the area first in square feet of this triangle. So if I'm given two sides, or I'm sorry, if I'm given two angles and a side, right, I would need to first find the third angle. So if I take 180 minus 42 minus 65, I think that we get this angle would be 73 degrees. All right, so then I'm going to use this formula. Okay, so the one side that I have is 299, so 299 squared times the sine of these two angles here, so sine of 42 times the sine of 65, all over 2 times the sine of the opposite angle. And I can plug all of that into the calculator. And when I do that, I think we get 200, oops, I jumped ahead. We get 28,346.71. What was that? 346.71. So now, to find how many acres this is, okay, if I know that 1 acre is 43,560 square feet, I'm just going to take this number and divide by 43,560. Okay? Then we get this value here. Okay, 0.6507509352. So that's how many acres, right? Roughly 0.65 acres. So that's the answer to the first part of the question. Then the second part says, well, how much is this land going to cost if it's $3 million per acre? Well, then I would just take my total number of acres and multiply that by 3 million. Then I get $1,952,252.81 if I round that to the nearest cent. Okay, so those would be my two answers, right? This would be the number of acres, okay, and generally we'll round that to two decimal places, and then this would be the cost of that piece of property. All right, let's do one final example. Okay, in this one, we are going to find the area of an irregular quadrilateral. Okay, we can actually use these ideas of finding areas of oblique triangles to find areas of any polygon. All right, so what we want to do is split this figure up into triangles. Now, since I'm only given one angle in this case, I do not want to split that angle. All right, so I don't want to draw a line here to create two triangles. In this case, I have to draw my line here to create my um, two different triangles. Now, if we were given other angles, if we were given all four angles, it actually wouldn't matter if I drew my line here to create two triangles or if I drew my line here to create two triangles. Okay, but in this case, since I'm only given one angle, we need to split into two triangles this way. Okay, so now if I want to find the area of each of these triangles, well, in this top one, I actually have enough information already, right? Because I have two sides and the included angle. But in this one down here, I do not have enough information. So what that means is I'm going to actually have to find the length of this diagonal here. So to do that, we can use law of cosines with this top triangle, right? We can say that this side, if we call it x for now, we can say x squared would equal 45 squared plus 25 squared minus 2 times 45 times 25 times the cosine of their included angle. Okay, we can just go ahead right off the bat and take the square root of both sides. So if I put all of this into the calculator, I think we get this value right here, 58.476878. So now we've talked about before, right? Generally for an intermediate step, we don't really want to round. Okay, so I'm actually going to store this value in my calculator as A. Okay, and you can, if you're storing values, you can store them however you want. All right, so I'm going to store that as A. Okay, so what we just found, right, is that this side is about 58.48, and we put that as capital A in the calculator. We stored that as A. So now I have enough information to find the areas of these two triangles. Okay, for the top one, we can just use our side angle side formula. Right, so if we call this area K1, I can say that this area is going to be 1/2 times 25 times 45 times the sine of 110. And if we put that into the calculator, I think we get about 528.577. Okay. Now, again, I'm going to go ahead and store that in my calculator as K. Okay. So I'm just going to make a note that I made that K in the calculator because we're going to ultimately need to add these two triangles areas together. So this one we can call K2. And now in this case, I don't know any angles, but I know all three sides of this triangle. So I could use Heron's formula. We could have actually done that in the first one as well. but this is a little bit less work, right? So first, I'm going to need to find the semi-perimeter, right? So S. So I need to add all three of these together and divide by 2. Now, since we called this A, I can just say that this is A plus 55 plus 60 all over 2. And you can put that into the calculator, all right? And we get about 86.7384. Now, I'm going to go ahead and store that as S just to make plugging this into the calculator a little bit easier, right? So I actually stored this as S. So now I can say that my K2, this is how I'm just going to type it into the calculator, right? I can say this is S times S minus, and now this side is still stored in the calculator as A, and then times S minus 60 times S minus 55. Okay, so if I type that into the calculator, we get that that second area is about 1,442.33. And then finally, for the final answer, to get the area of this quadrilateral, I need to add this area with the area of the first triangle, which I stored as K. So my final answer, okay, again, if we want to round this to 2 decimal places, is going to be about 1,970.91. And I believe our units were feet. Yeah, so this would be square feet for my final answer here. Now, we can use this idea, like I mentioned, to find the area of any polygon given enough information. Okay, so on one of your homework problems, there is actually a pentagon that you're going to have to split up into 3 different triangles and find the area of those 3 triangles. All right, so that is it for this video. The final question is going to pop up asking you what questions you have.